Hello students, now in this session of video we will discuss class 12th maths and a very important theorem, Rolle's theorem. Today we will discuss what is Rolle's theorem, how can we prove the Rolle's theorem and the problem based on the Rolle's theorem. Clear? So first of all we will understand what is Rolle's theorem. So that we have given f is a function such that in a closed interval. Clear? So we have already discussed what is closed interval, that in closed interval a and b also included. Clear? For a closed interval a comma b to domain and the range is real number, be a continuous on a comma b and differentiable at open interval a comma b such that fa is equal to fb, then there exists some c in open interval a comma b such that f dash a is equal to 0. So this is the definition of a Rolle's theorem. Now we will understand the meaning of this one. Clear? So we have a given function. In that given function we have a given domain, a interval, a closed interval. Clear? डोमेन क्या है, क्लोज इंटरवल है एंड रेंज अ रियल नंबर, बी अ कंटिन्यूस फंक्शन ऑन. सो एफ क्या होना चाहिए, कंटिन्यूस होना चाहिए इन क्लोज इंटरवल ए कॉमा बी. सो फंक्शन मस्ट बी कंटिन्यूस ऑन क्लोज इंटरवल ए कॉमा बी एंड डिफरेंशिएबल एट ओपन इंटरवल ए कॉमा बी. क्लियर? क्लोज इंटरवल के लिए कंटिन्यूस एंड डिफरेंशिएबल एट ओपन इंटरवल a comma b. Why it is open interval? Because the function cannot be differentiate at the corner point. So that's why we will not taking corner points. So a and b are the corner points. ठीक है, differentiable corner points पे नहीं हो सकता, इसलिए हम लोग इसको clear. So we have already discussed about the differentiation. Differentiation is a unique tangent at every point. Clear? That is called differentiation. Such that fa is equal to fb means फंक्शन fa a पे जो फंक्शन की वैल्यू होगी वही वैल्यू फंक्शन की b पे होनी चाहिए. ठीक है, एक एग्जांपल से हम लोग समझेंगे. देन देयर एग्जिस्ट सम c मीन्स अ पॉइंट c लाइज बिटवीन दीज टू ओपन इंटरवल a कॉमा b. c को इन दोनों पॉइंट्स के बिटवीन होगा जहाँ पे f डैश c इज इक्वल टू 0 मीन्स फंक्शन का डिफरेंशिएशन 0 होगा. और function we can say that if we draw tangent on that point it must be parallel to x-axis. Clear? Slope is parallel to x-axis. Clear? We'll understand that by an example. Okay, so how you prove that existence of a Rolle theorem? Clear? Rolle theorem is exist. How you prove that? So we will understand that existence of a Rolle theorem. F such that it is belongs to closed interval to real number. F is continuous on closed interval a comma b. F is differentiable on open interval a comma b, or the value of function at a must be equal to the value of function at b. Clear? If these conditions are satisfied, so we can say that, then we can say the Rolle's theorem satisfied. Clear? Okay. Now the physical meaning of that one, the graphical will understand the Rolle's theorem. Clear? So there are two possibilities. One is this: the the curve is open on upper side. Clear? This is a parabola. The parabola is open on upper side. So fa, fb. So this point is a and this point is b. At point a the value of function is fa. At point b the value of function is fb. Then c is any point. c इस कर्व में कहीं पे लाई कर रहा है between. इस कर्व में c is कोई point है which is, if you draw tangent on that point it must be parallel to. So if we are drawing a tangent on that point, so that must be parallel to x-axis. Clear? Okay. Next is the parabola is open on lower side. So FA and FB. FA, at A the function value of FA, at B the value of function is FB, and C is any point on the curve. C is this point on the curve that must be equal to that. If we draw a tangent on that point, अगर हम इस point पे tangent draw करते हैं, so that must be parallel to x-axis. Clear? Okay. Now next is that. Okay, now problem related to Rolle's theorem. What kind of problem raised due to this Rolle theorem? And the problem is that first kind of problem is to check the applicability of Rolle's theorem to given function on a given interval. So the function is applicable. Clear? The function is applicable for a given interval or not. Suppose that we have given a function f. So that function is applicable to use Rolle theorem or not. So we will check applicability. So it is applicable or not. Second is to verify Rolle's theorem for a given function on given interval. So we have given any interval and we have to verify. So I have already discussed about how you verify that. Clear? Now we will take one example related to Rolle theorem. Okay, now we are solving type 1 question to check the applicability of a Rolle's theorem. Clear? That Rolle theorem is applicable for that or not. For that, fx is equal to the modulus of x on interval is given to a closed interval -1 to 1. So we have to check that the modulus function x is applicable for the Rolle's theorem or not. So what first is the step, first we have to find out the continuity of a function, that function is continuous or not. So first of all we will see that this function can be written as minus x when it is between 0, -1 and 0, and x when it is greater than 0 and less than 1. Clear? Because we have given a interval. So we will check that. So consider a point x. We have now left hand limit and right hand limit. We will solve this. We can find out. We know that if the left hand limit and right hand limit are equal, then we can say that the function is continuous. So we will check. We have find the left hand limit is 0. Similarly, we will find the right hand limit. It is also 0. Clear? Now function we can say the value of function also f is equal to 0. So left hand limit is equal to right hand limit is equal to 0. Now we have to check the differentiability of a function, given function. Clear? So what we have to find the left hand derivative and right hand derivative. So we have given that the left hand derivative first of all we will find. So we get at left hand derivative we get -1. Clear? And then we find the right hand derivative, so we get 1. So left hand derivative is not equals to right hand derivative, so it is not differentiable. So if it is not differentiable, so we can say that Rolle's theorem does not exist. Does not exist. Clear? Okay. Now second type of question we have that verification of Rolle's theorem for a given function defined on given interval. So we have to verify the Rolle's theorem. Clear? For that, first of all, same conditions. We have given function that is a polynomial function. So we know that the polynomial function is what? The polynomial function is continuous and differentiable. Clear? So this polynomial function is continuous and differentiable. So we can directly say that fx is continuous on 2 and 3 closed interval, and x is continuous on closed interval and differentiable on open interval 2, 3. So f2 is equal to 0 and f3 is also equal to 0. So means fa is equal to fb. The condition we have to find for fa is equal to fb. So finally we will see that fa is equal to fb. Thus all conditions of Rolle's theorems are satisfied. Then of C, any point is between them. C is any point on the given function. Clear? C कोई दूसरा point होगा. Then f dash c is equal to 0. So we have fx is equal to x square minus 5x plus 6, and f dash is equal to 2x minus 5. So we can finally find the value of this is what we have. We have given fx is equal to x is equal to 2.5. Clear? We put it 0. F dash is equal to 0. So x is 2.5. So 2.5 is a point between 2 and 3, where if you draw the tangent at that point which is parallel to x-axis. Clear? So this is our type of question based on Rolle's theorem. Now next video we will discuss mean value theorem.